Hello, it's Mr. Van Ong here with Distance Learning Week 5, Day 5. And we are on page 929 in math today. We're going to be classifying quadrilaterals. We're going to be classifying quadrilaterals, as I spoiled for you yesterday, based on two criteria. How many of their opposite sides are parallel? And do they have right angles? And also if some of the sides are congruent will matter too. So they've got a nice little diagram here, and I'm going to kind of make my own version. Remember, we could have made in some past years, I've made like a huge poster that shows like there's a bunch of figures, and from those figures you can then call some of them polygons, and then each of those polygons, based on the number of sides and angles, there's a special word for, and then some of those we have special words for too. Again, that classification system. So what we want to look at is that quadrilaterals come in three initial states based on how many parallel sides they have. You've got a good old quadrilateral like this. Hey, there's a quadrilateral. It's got four sides, and none of it has no parallel sides. We just call this a quadrilateral. So this guy, nothing special about him. Sorry. Nothing special about that. It's just a quadrilateral. Now, if a quadrilateral has one pair of parallel sides, like the ones I drew on the board yesterday, if it's got one pair of parallel sides, then it's called a trapezoid. So I'm going to draw a trapezoid over here. Oh, I'm going to draw it a little bit nicer. And I'm going to help. Oh, I'm totally off the screen. Sorry about that. I know you really want to see me. So I've drawn those symbols there to make sure that you see that even though I didn't measure it and draw it perfectly, I'm telling you these two lines are parallel. But Mr. Van Dunk, they're actually not parallel. I know, that's what I'm saying. They're not actually parallel. If I were to get out a ruler and draw them forever, they would eventually collide. But I'm telling you, I meant to draw them parallel. That's why I put the symbol in there. Special word for this is trapezoid. This is, again, absolutely no new information to you today. It's just a reminder of things you've learned in the past. Trapezoids, one pair of parallel sides. And then there's another, if there's two pairs of parallel sides, then it starts to get pretty interesting. So if there's two pairs of parallel sides, something like this, there's a parallel side, and here's the other pair of parallel sides like that. So I've drawn one hash mark there, so showing that these are parallel, and two showing that these two are parallel. Two pairs of parallel sides is a parallelogram, which I always want to just double check. Yeah. A parallelogram has two pairs of parallel sides. And then we really drill down into parallelograms of a lot of other special words for them. So a parallelogram then gets classified in one of two ways after that. If the parallelogram, it might just be done at parallelogram, but if that parallelogram has any right angles at all, then it's called a rectangle. So if it's got any right angles at all in it, then it is going to be a rectangle. Now, I said any right angles at all in it, and then I drew four right angles. That's because you can't draw a parallelogram with only one or two or even three right angles. Try it. You pause the video and mess with that just for fun. You can't do it. A parallelogram has to have, if it's got one right angle, it's got four right angles if it's a parallelogram, okay? Otherwise, when you start messing with the angles to make them not right angles anymore, you're going to mess with having two parallel sides. You'll either have one pair of parallel sides or you'll have none. So, okay. The other thing we look at is, hey, are all of the sides congruent in the parallelogram? If all of the sides are congruent in the parallelogram, so if I had drawn that more like this, so it's a parallelogram, and I'm going to show that I've meant to draw all those as being congruent, all the sides. Then the special word for this is a rhombus. By the way, rhombus is one of those annoying words where if there's more than one of them, it's not rhombuses, it's rhombi. Okay, so rhombi or a rhombus has all of the sides. Mr. Van Dong, you drew a diamond. Deep rest, Mr. Van Dong. Whoever, anyway, I wish we didn't use the word diamond. Okay, diamond is not a geometrical term for polygons. A diamond has nothing to do with polygons, ever. It never does. Okay, so I really wish we didn't use the word diamond with little kids when we're describing this shape. This shape is a rhombus. It's not a diamond. Please tell your little cousins and brothers and sisters and nieces and nephews, and one day your children, if you have them, don't use the word diamond. Tell them it's a rhombus and set them up for success. It's a rhombus mathematically, okay? Diamond is something different. It doesn't have anything to do with polygons. So, okay, so that's a rhombus. Now, if the parallelogram also is both a rectangle and a rhombus, there's another special word for it, and that special word is square. So it's got the right angles and the sides are all congruent, then it's a square. So we think of square as such a basic shape. It's like one of the first shapes that little kids recognize. They're like, that's a square, and they know what it is. Yeah, good job. Well, it's actually really complicated why it's a square, isn't it? It's a square because it's a polygon with 4 sides, which is a quadrilateral, that has 2 pairs of parallel sides, making it a parallelogram, with all sides congruent, which makes it a rhombus, with 4 right angles, which makes it a rectangle. And because it is both a rectangle and a rhombus, it's called a square. Okay. Again, is a square a rhombus? Yes. A square is a special type of rhombus. Is a square a rectangle? Yes, it's a special type of rectangle. Is a square a parallelogram? Yes, it's a special type of parallelogram. It's just like lots of other things that we classify. It'd be sort of like asking, hey, is an equilateral triangle a triangle? Yes, it is. It's a special type of triangle. Okay, so we're drilling down deeper into our classification. If we're going to use like an example from biology, is a human an animal? Yes. Yeah. Or is a human a mammal? Yes. Is a mammal an animal? Yes. Now, are all animals? No, they're not. Are all parallelograms squares? No. Are all rectangles squares? No, they're not. So as we get more specific, we're getting to a more special version of the shapes above. So you've probably heard people say, is a square a rectangle, or is this a rectangle is a square? And they're trying to like get you to say something wrong or something like that. And what you need to remember, I like going to the biology example best. The more specific word that you can use, I'm a human. I am also all of the things above that. I am a human. Or let's change gears, because not all of us are as familiar with the how we classify life in bio. You did in 4th grade, but anyway, let's think about location. Let's think about where we are. The most specific definition of where I am right now is standing in front of the whiteboard. I'm standing in front of the whiteboard on the north side of my classroom. I'm standing in front of the whiteboard on the north side of my classroom in room 303. I'm standing in front of my whiteboard on the north side of my classroom in room 303 on the 3rd floor. And then I can keep going on the 3rd floor of Sharpstein, which is in Walla Walla City, which is in Walla Walla County, which is in Washington State, which is in the United States of America, which is in North America, which is in the Northern Hemisphere, which is on Earth, which is in this solar system, in this local neighborhood of the Milky Way galaxy. So, am I in the Milky Way galaxy? Yes. I am. The most specific version of me, of where I'm standing, is also standing in all of those larger things above it. But is everyone who's in Walla Walla right now in Sharpstein Elementary School? No, of course not. Is everyone who is on Earth in North America? No, they're all over the place. So thinking about maybe your location and how specific you are sometimes can be helpful in understanding how this classification works. Is a square a rhombus? Yeah, because it's a parallelogram that has all congruent sides. So yeah, it's a rhombus. Is a rhombus a square? This one isn't. This rhombus that I've drawn here is not a square because it doesn't have right angles. So it's just a rhombus, which is a special type of parallelogram, which is a special type of quadrilateral, which is a special type of polygon, which is a special type of figure. Okay, enough. All right. I'm going to have you work on, well, let's do number 2 together. Here we see this cool looking building that looks like it's going to fall over, but it won't. How many pairs of parallel sides does it have? It has 2 pairs of parallel sides. The opposite sides are parallel. Therefore, it is a parallelogram. Now, it wants you to also notice that the opposite sides are parallel and congruent. Cool. That will always be true of every parallelogram. Every parallelogram you draw is going to have opposite sides congruent. But I want you to focus on the opposite sides being parallel instead. Okay. All right. Down here, we've got a spoiler alert. It's a rectangle. The opposite sides of the quadrilateral they're parallel. And they're congruent because they're parallel. And there's 4 right angles. So it's a parallelogram with right angles. Therefore, it's a rectangle. Is it a square? Well, this rectangle doesn't have all of its sides congruent. So it's not a square. It's just a rectangle. Okay. The design below is the same quadrilateral repeating over and over and over again. What are the attributes of the quadrilateral? Now, they want the smallest set of lines, like one of those little things outlined in blue. Well, how many of its sides are congruent? All of them are. All of them are. And are the opposite sides parallel? They are. So we've got a special parallelogram right here. This little blue shape is a parallelogram. And if all of its sides are congruent, it makes it a rhombus. Is it a square? No, because there's not right angles. But it is a rhombus. So it's a rhombus over and over and over and over again in a cool design. Okay, you're going to work on the rest of the assignment following the directions listed there. When it says classify a quadrilateral, remember, classify means give the most specific name you can to it. So if there is a picture of a square, which there's not, but pretend that one of those was a picture of a square. If it said classify the shape, you would need to write square. That's it. Because when you say that something's a square, you're telling me all of the other information about it already. You don't have to write that it's also a rhombus, also a rectangle, also a parallelogram, also a quadrilateral, also a polygon, also a figure. Don't do that, okay? Just telling me a square. It's the most specific name for it. Okay, the most specific name for it tells me everything I need to know. So make sure that you do that. Now, it also says describe the attributes. So that would be like, well, why is it a square? It's a square. If I'm going to describe the attributes, I would say opposite sides are parallel, all sides are congruent, has right angles. That's what makes a square, all right? So you're going to do that on those first 2 problems and then answer the other questions there as well. Again, working for 45 minutes. Minus the length of this video, or until you're done with the pages 931 and 932. Have a great weekend. You're almost there. Keep working hard. Miss you guys, and I'll talk to you later.